So thanks everyone. Welcome to our second AMA session of the year. We are excited to have both mentees and mentors joining us today, as well as members from EPP and CSPG GeoMatch. And there might be some of you who just came across our posting on Instagram or LinkedIn and just have welcome to join us. This so far is our most successful AMA to date with over 30 people registered. And I thought it would be an interesting exercise just to look at the past few sessions that we've had, and then do some data sciences myself to see, what can we expect for the next two sessions. And, this trajectory looks pretty good. By the end of the year, we should have maybe 140 people joining us. So just a few bookkeeping items. My name is Jordan Vandean. I'm with the CSEG Mentorship Committee. Jeff Calvert, he'll be joining me today. He's sort of my producer. And we asked and you responded. We wanted to know what you guys were interested in learning about, and data sciences was very high up on the list. Some of the most highest respondents that we had. And so we thought, grabbed a couple of professionals here. We have Marc, Boulet, and Brian Emmerson, who will introduce more later with us. And if this is your first time joining us, you're probably wondering how this works. First and foremost, this session is for you. We want you guys to drive the conversation. I have my own list of questions that I can ask Marc or Brian, but I can bug Marc at any time since he's a coworker of mine. So we want you just to submit questions, and you can do that in a multitude of ways. The first is, you can raise your hand. There should be an option near the bottom of your screen. Jeff will keep track of the order in which they came, and make sure we get to your question sort of in a queue format. And if you can, put your video on, use your microphone. We'd love to hear from you guys, see what you look like, get you recorded on the video here. But if you're not comfortable with that, there's also a chat format you can use. Feel free to type it in the public chat, or you can send a private message to Jeff himself, and we'll get to you in order. So with that out of the way, I'd like to introduce our two guests formally. First, Marc Boulet. Marc is a colleague of mine. He graduated from the University of Calgary with a Bachelor of Science in Geophysics in 2007. He's worked as a geophysicist for the likes of Repsol, formerly known as Talisman, Apache, and then joined Synovus up until 2017, where then he switched over into the data sciences career, in which he completed his Master's in Science and Analytics from Georgia Tech. Go Yellow Jackets. And now he's currently the data science management lead of oil sands and geology at Synovus. So say hello. Hi, Marc. How are you?
Hey, everybody.
We're also joined by Brian Emmerson. Brian has an undergrad and master's in experimental and theoretical physics from the University of Cambridge, in which he graduated in 2003. However, he wasted no time and just stayed at Cambridge and completed his PhD in geophysics and seismology in 2007. He then worked as an exploration geophysicist, also with Talisman, but over a different time than Marc, looking around the world in exotic places like Papua New Guinea and Kurdistan before he decided to move to the WCSB. Also around the same time as Marc, 2018-ish, he started working as in the data sciences realm with the likes of Verdazo and Petronas. But as recently, I think as recent as January, he took a position with Suncor as manager of advanced analytics. So with that, I'd like to welcome you, Brian. How are you today?
I'm good, thanks. Hi, everyone. Yeah, Suncor is only 2 weeks old for me. I joined last week, so don't ask me anything about that.
Okay, yeah. No Suncor questions. All right, those are off limits. Okay, and I gave Marc and Brian just a tiny bit of homework. We thought it'd be a good way to start off with just a bit of anecdote. Just tell us a story about yourself. It doesn't have to be professional. And with that, I'll let Marc go first.
Yeah, thanks for that, Jordan. So as Jordan indicated, I graduated in 2007, but that doesn't look like it makes a whole lot of sense when you see what I actually look like. I actually did graduate in my 30s from geophysics. So before that, I was actually a flight attendant for a number of years. And one nice little anecdote is that over the course of 10 days, I traveled 50,000 kilometers. From Calgary, I went to Toronto and back, then to London and back, and then to Honolulu, then to Sydney, then back to Honolulu, and then back to Calgary. That was over Christmas, and I don't remember a thing. It was a lot of fun.
So much fun, you don't even remember. Well,
that's kind.
And Brian, I'd like to hear a story about your past. Are you willing to share with us?
I can give you a semi-professional anecdote. my first job out of school was as a software developer. I graduated with a degree in geophysics and thought, what I really like doing is writing code, and therefore I'm going to go off and be a software developer. And I worked for Bloomberg, the news agency, and had a really exciting job where we worked on probably one of the first 100 iPhone apps. App Store had just been released, and we got to build a very quick prototype and put it out there. But there was one crucial bug in the first release of the Bloomberg News app for iPhone, and that was my index out of bounds error. So not a great start, and not something I was really good at, I don't think. I always just like hacking code together and not have no kind of skill for the kind of professional software engineering element. So yeah, that's my first career and first unsuccessful one, I would say.
Very interesting. It wasn't a British pounds to US dollars error sort of thing, which is very thankful.
Oh, that error was in there too, but yeah.
Awesome. Those are some great stories. And so I think the most obvious question, and while Marc and Brian answer this, maybe the rest of you guys can think of some questions that you'd like to ask yourself. The most obvious question I can think of is, how did you guys switch from geophysics to this data sciences world? And Marc hosted a fantastic lunch and learn at Synovus, and someone asked him this exact same question, and I really loved the response. So with that, I'll let Marc, you answer that first, please.
Yeah, it's too bad you don't have a filter for me, because sometimes I kind of regret that answer that I gave at Synovus, but I said job preservation. And the reason why I said that was that I consider myself a relatively poor geophysicist. I don't have the confidence to just say, hey, I found a great play and you should drill there. I always like to have some numbers in my back pocket. And so as a result, in the course of trying to work up a play, I actually just honestly wanted to correlate some seismic attribute values to geological attributes to production numbers. And, we've all tried to do those kinds of things in Excel, and it takes a long time. And if you want to do a multivariate analysis, it's tedious. So a friend of mine actually just said, hey, she worked at Canadian Discovery at the time, and she was showing me some work they had done, and it looked awesome. There's a big decision tree and everything. And I said, well, how did you do that? And she said, well, I used R. And I said, well, yeah, that's a letter, but I don't know what you're talking about. But R, of course, is a programming language. And that basically just started off my career. I thought I was going to take a 3-week course and then I'd be all good to go. And it's been almost 4 years later and I'm still in school. I actually haven't completed my master's yet. I'm still in progress. But that's how I started. I just wanted to do a better job at my day-to-day job and drill better wells.
Yeah, I like when you said, there's a lot of interpretation in geophysics and you wanted something more concrete, more tangible. I think that resonates with anyone who's looked at seismic and you're trying to tell your geologist, what is the porosity here when you look at a wiggle sort of thing. So I really related to that. And Brian, could you tell us your story of how you got into data sciences?
Yeah, so as I alluded to, I definitely always had like a passion and an interest in coding, but never really from the kind of polished professional software application point of view. And actually, Marc, I didn't know if I knew this about you, but I think I know the paper that you're referring to from Canadian Discovery in about 2016, and I don't know if the author realizes how much of an influence that has had on people in the industry. But yeah, I remember reading that paper around the same time, and really interested in the techniques that were in there. And so I had this kind of interest in coding, interest in scientific computing and solving problems with code. And this just seemed like the perfect intersection with kind of my day-to-day job. And I would second Marc's opinion of himself, not about you, about me, and saying, I like geophysics, but I always would kind of err on the kind of more numerate and statistical analysis side of it, rather than coming up with a creative interpretation and saying drill here. Certainly I was always biased towards kind of automating stuff and processing data as quickly as possible. So it was kind of a natural fit, it felt, and it's been really enjoyable ever since, and about the same time frame as Marc.
Wow, that must be a pretty good paper. I'm gonna have to look into that one. Let's look out into the crowd. Jeff, do we have any questions from our guests so far today?
We have one question to kick it off. It's going to be a little bit general, but we'll start with you, Marc. Let's say I'm in university, I'm going to graduate, and I want to get into data analytics. What should I be looking into? Should I be looking into online courses? Should I be looking into continuing my education at the university? From your experience, what have people been doing in this field?
Yeah, that is a broad question. Basically, anything is possible and everything is possible, which of course is both a blessing and a curse, right? The education aspect of this stuff is readily available. It's wonderful. You can go anywhere and learn a bunch of stuff. To me, the key aspect, and I think this is what people keep telling me about data analytics, is that I have a lot of passion about it. I really like this stuff. And I think that's the key part, is finding something you're really passionate about, and just find a project that you have some data and you want to figure something out with it, and then get those tools in place to be able to do that. For instance, one of the first projects I did was a friend of mine was moving to an unnamed neighborhood. I used to name the neighborhood, but I don't want to get in trouble. And I thought, wow, you have a young family. It's a scary area. You shouldn't move there. But I thought, well, guess what? Maybe I'll go check out the Calgary Police Service website and see what data is available on that. And so I actually put together a nice little map, and it was all color coded and gave me an idea about, how safe his neighborhood would be versus where he used to live. And sure enough, I was right. It's not a safe neighborhood at all. So that was kind of fun. But then I kind of built on it a little bit more. And then I actually had that kind of up and running. And believe it or not, it was kind of my business card to get my data science job within Synovus, even though it wasn't a Wells interpretation or anything like that. It was just a quick little thing that I whipped up, with a nice map layer and some shape files and some relatively rudimentary analytics behind it. But I was willing and happy to put the effort into it, and I think that's what showed, and that was the key aspect. So there's lots of tools out there. That is not the issue. It's just making good use of them and having the passion to kind of drive it through.
Ryan, would you have anything to add? How people should start investigating whether or not, data analytics, if it's something they're interested in or not?
Yeah, I'd kind of second Marc's comment about passion and interest. There's a component of the field which I think it's really just about interpreting data, which a lot of geoscientists are really good at, and finding patterns in data. And then there's another side of it which is about sitting down and knocking out code, and not everyone likes doing that. You can convince yourself that you maybe want to try it, and I would 100% encourage everybody to at least try it if they have never written code, because but some people find it's really their passion, and others are like, oh, this error again, I don't really want to deal with this, and it can be incredibly frustrating. So you verify that it is something you're passionate about. I remember reading quite a nice summary from a data scientist who's also a former geologist down in Houston, who made the transition to work in data science, and that's what he does professionally now, and about how people get into the field. And he basically listed 3 ways in, which I think is a fairly good summary. One is that people generally have kind of numerate backgrounds, maybe an advanced degree in a scientific discipline, and then they augment that. So they've got kind of the natural foundation for data science, but then they augment that with courses that are, as Marc alludes to, but very widely available. There's a huge amount of resources online that you can look into. So they take their advanced degree and they augment it. The second way, he said, was that a lot of people take like an intensive boot camp, like or a large whack of courses over maybe a few weeks or a few months. And then the third is the kind of the master's program or another advanced degree. And I think it's easy to just dip your toe in the first 2 options by looking at what courses are available. Many are available for free or very little charge, and just seeing if it's something that takes your fancy, like it's something that you're really interested in. I always think that jumping in and saying I want to go do a master's in it and that's going to set me up is, I think you should at least dip your toe in the water first and decide if it's something you want to get into.
That's all fantastic advice. I love the list of 3 there. I think it'd be good just to back up a tiny bit. A lot of the people joining us tonight probably don't have much professional experience, and so they haven't tried, correlating the data that they're working with, whatever type of algorithm they want to use. They don't have that experience, and so they don't even know if this is a passion for them. Maybe if you can, in a couple sentences, because you can probably spend all day on this, how would you describe data sciences or data analytics, just for people who don't have much professional experience?
I would say it's the process of finding and formalizing patterns in data, doing statistical analysis and using a computer, using a machine to drive trends out of data. So the kind of thing that you would maybe spend a lot of time picking through manually, trying to automate and make that process a lot more rapid and a lot more easily done, using a wide array of algorithms, which, you know, as a first pass, you don't need to know really well to just run one and see how it does. And over the course of time, you understand how they start to behave. But it's taking data and picking it apart with a series of moderately advanced to very advanced tools. But some of them are very, very simple, and they're just widely available now.
Mm-hmm. Marc, would you have anything to add to the description of data analytics?
Absolutely. I'll just put an extra bit of flavor on that. In essence, none of the aspects of data science are new. Some of them are 50, 60 years old. Even deep learning algorithms have been around for 30, 40 years. It's the confluence of having computing capability and easy access to statistical algorithms in coding languages that has really kind of brought it together. And then the tools to be able to handle very large sets of data. And so all of these different pieces have been around in different ways, but now they've all kind of come together to kind of create this world. For instance, like deep learning really was around for many, many years, but it was only with the advent of GPUs that it kicked off in 2012. I mean, it's not that long ago, right? Even though the research had been done many times before. So I think that's the big thing, is that nothing is new here. Statistics has been around for a while. Computers have been around for a while. Algorithms have been around for a while, but it's just kind of how it's been starting to mesh together into this kind of hybrid thing that's made it very powerful.
Awesome. I think that's a great foundation for us to work with. Jeff, how are you looking for questions?
Yeah, we're starting to get a few more in. First question up here is, what do you think is the unique advantage of data scientists who have a geophysics educational background compared to other degrees? Maybe you can start off with that, Marc.
Yeah, that's a beautiful softball question. In essence, we have math in our backgrounds. We have physics in our backgrounds. No joke, I have never used my actual geophysics degree more now. I've used it much more now than I ever did as an interpretation geophysicist. I actually need to know my linear algebra. I need to know my multivariate calculus. I need to understand statistics. You really need to understand what is going on there. So in my degree that I'm doing now, I do see people who come from other non-STEM backgrounds, and they really suffer not knowing those fundamental math and physics. Whereas if you have that in your background, you're far, far ahead. And it's quite funny now, when I mentioned that I have a geophysics background in my data analytics world, they're like, ooh, wow, that's cool. Like that, you sound really smart. So yeah, you do definitely have a leg up with a geophysics degree.
Mm-hmm. Brian?
Yeah, I think the other thing that's, I totally echo Marc's sentiment, by the way, in terms of the kind of being an interpretation geophysics, somebody working in interpretation geophysics anywhere in the world, like a lot of it is very kind of creative, and you don't necessarily, unless you're deep into kind of reservoir characterization at quite a specialized level, you tend not to touch a lot of that kind of mathematical underpinning. And I would second that. You know more than you think you know. Like, you may have worked as a geophysicist for a few years and realize and think, I don't really know a ton of math. You do, compared to the kind of general population, and you've covered a lot of the ground previously. I remember, you feel like a genius watching the fundamentals of linear algebra part of a course over by just watching it on 2 times speed, but you're just going through it just to refresh your mind. But yeah, you do know a lot, but you've also got that comfort with data, with chewing through data in different fashions, taking different views of data. You're just very comfortable manipulating data and trying to pull trends out of it as well. And that's a sort of, I'd say, a secondary skill that, again, is not necessarily something that everybody can do.
I would just, sorry, Jordan. I would just indicate too that I would say geophysicists were some of the original data scientists, like a generation ago. They all hacked their way through things. They coded up their own solutions because those tools didn't exist, right? And then software came around and took a lot of that burden off of us to do our work. But it is part of the lineage, definitely.
That's a really good point. We have a lot of people still in school who are joining us tonight. Do you think it would make a lot of sense for them to, complement their geophysics degree with a minor in stats, or, a dual major if they still, if they're in their first or second year? Does that make a lot of sense, do you think?
Yes,
Yeah.
100%. Yeah, like, I picked the second course of interest, or the second sort of discipline of interest carefully. And like I say, it's got to be something you're interested in. I think if you haven't taken a course that involves coding, I think it's cool. Look, you maybe could have got by with that, a few years ago, and not needed it, but you absolutely should at least understand how these things are put together. And if you go to a university course and they say, okay, we're going to teach you kind of fundamentals of Fortran, or maybe C or C++, ask for a higher level, look for a higher level language that can kind of get you into the sort of the fundamentals of programming without necessarily getting into the kind of fundamentals of how a computer's put together. Mm-hmm. Because I wouldn't say it's necessarily a high barrier to entry, but those higher level languages like Python are so much more powerful, and there's so much more material available to support you doing that. So I think, yeah, if you haven't had a course, if you're in a science discipline and you haven't done coding, you haven't taken a course in coding, I think that's absolutely at least worth trying.
That's fantastic advice. Jeff, do we have any questions? I think I saw a video pop up.
Yeah, I think we're gonna have Cole ask a question verbally.
I just got a quick question, but I'll just add something to for the trying to dip your feet in thing. U of C has a data science minor that they offer now, and I think if you play your cards right, it's only like 5 additional courses, so like 1 extra semester. So that's what I did, and it was a good way for me to sort of get a sort of taste of things. I guess for my question that I was wondering is like what sort of projects should one aim to have on their GitHub, or showcase that for someone, if you hand them a resume with your GitHub link or something like that, that they kind of have a general idea of what they're doing? Because I know some people want to, and it's really tempting to try and like jump into machine learning projects right away, but is there sort of like a stepping scale of stuff you should show before that, or work your way up to those?
Marc, do you want to take the lead on this one?
Yeah, sure. I would honestly say that, participating in Kaggle projects, for instance, or Kaggle competitions, nice idea, but unless you're going to win them, I don't think there's much value from a marketability perspective. I'd say projects that really have character, to be honest, and kind of reflect who you are, make a big difference. It's very difficult to do oil and gas related data science projects just because of the nature of the data. It's very hard to get a hold of, although some of it's available. So I think going down the route of showing like a really neat project is, to me, I think the best approach right now. I'll give you a very quick idea of what Everett Robinson over at ConocoPhillips, he just finished his master's degree, and while he was working at home, he noticed that he just sits beside his balcony, and he noticed that there were different animals that come up on his balcony all the time. So he actually set up a little webcam and a Raspberry Pi, and then coded up a whole thing so he could identify the different animals coming up to his window, for instance. And it uses PyTorch, like it has some deep learning, it has some computer vision. It took about 50 lines of code, but boy, that sounds pretty cool, doesn't it? Right? So, and it's similar to, just portray who you are and what you can do, and just kind of think a little bit out of the box. I think that would be the key thing, because a lot of people will take like the IRIS data set and do something, for instance, that's been done. I hate to say it, try something different, smash different things together. And I think that's where you'll show your true value.
Awesome.
I think one thing I'll add to that is like nice visuals, or kind of a powerful summary visual. It's just 2 things. One is that it's kind of eye-catching. It's very easy to kind of get somebody's attention and show them what you've done. The second part of that is that's a key part of the job, is boiling stuff down to visuals that people can relate to. It's a thing that you're used to doing in a kind of science discipline anyway, but it's a great way of communicating what you've done. I mean, the fact you modified some base class into some slightly different version, and that's great if it's buried under the hood. Let your reader go and look there if they're interested. But if you think about it from the kind of advertising point of view, just a slick visual goes a hell of a long way. This is a personal issue of mine. Like, don't just write a blog post where you copy the manual page or the doc string from another website. It's just crowding the internet with noise.
Awesome. Cole, do you have any follow-ups to that, or did they sort of touch what you were asking?
I think they covered sort of what I was asking. Thank you.
Awesome. Yeah, so by all means, you guys feel free to ask some questions. We'll probably have it one question with one follow-up just so we can get to everyone who might have something to discuss. And on that note, Jeff, do we have any questions coming up?
Yeah, I got a couple here. So one question I have is, let's say I have a background in geology. I want to try to become more employable in the data science space, but let's be honest, I really don't like programming. Is this a prerequisite to be in a space, or can I be in more in a business kind of analytic role without having the programming skills? And maybe I'll give it to you, Marc, to try to answer that one.
Sure, sounds good. You'll see, I think both Brian and I have certainly a bias in this realm. The way I look at it is that somebody who can code is a mechanic, somebody who can't is a driver, right? So you could probably get to the same spot, but in order to get there the best way possible, you need to get under the hood. It is possible to do data science without coding. It's absolutely possible. There, you'll just have to rely on different pieces of software, different platforms, and ultimately that kind of tethers you somewhat too, as well, right? I did notice that in the geophysics world as well. Somebody who knew a certain piece of software probably couldn't work at that company because they didn't use it, for instance. And that was one of the major drivers for me to learn coding, is that all of these skills are completely portable. I can plop into right beside Brian and start working away because I've got all the skills that I've learned that are using open source technologies. So I think I am very biased towards the coding aspect because I think it brings a lot more than just, hey, I can code things up. But there are no code / low code options. It's just that they will guide you in different directions, and they may not be the directions you're looking for.
Yeah, I would say there are other avenues into the space. You maybe wouldn't call them data science roles, but visualization analyst roles, data analyst roles, which are more kind of, as the name describes, visualization driven, dashboard driven. I mean, that's a great skill in itself. The availability of dashboarding software, it will proliferate. It has proliferated already and will continue to do so. So it's great knowing tools like Power BI, Spotfire, Tableau, having some expertise in those. You can get a lot out of a tool like that and a lot out of a data set with those kind of skills. And there's no I don't want to say there's no data science involved, because everything here is on a spectrum, but there doesn't necessarily have to be a lot of code involved there. Or you can have somebody package code up for you within one of those environments, and you just use it. So that's a great way of getting into, like I said, the space, even if you wouldn't necessarily call it data science in the strictest sense.
I'll add a follow-up to that, and maybe I'll direct it towards Marc, because Marc, you're manager of your group. How much would you say of the work that your group does is focused on was code-based, ground up stuff you're creating, or something that uses a Power BI or a Spotfire that you're pushing out and publishing to help another group?
Our team is 100% code. So I would say if somebody, generally, if they're using Power BI or Spotfire, it's a talented engineer, geophysicist, geologist who picks up those skills and runs with it. It's when those tools hit a natural limit, like Brian indicated, if you need to do a little bit more sophisticated analytics behind it, that's when it comes to us, and then we code it up. So that's why it gives you that full spectrum of capability there. So yeah, no, we code everything.
All right, I think that's a great answer. Jeff, what's next in the queue?
Yeah, I got a question from Fernanda, and she's asking, can you discuss what you do in your day-to-day work from a data science perspective? What kind of projects you work on, for example? And maybe you can start this one off, Brian.
Yeah, it's a good question because there's quite a lot of mystery around in the field. Like I say, I'm very new to my job, and there's probably a bunch of projects I can't tell you about. But I would say that the kind of day-to-day work really revolves around gathering data sets, collating data that's maybe not in the best shape, exploring that data set using some, it's either simple to not so simple code-based techniques, and then building models. So by models, just trying to make predictions with a cleaned version of that data set that you have, that you've curated essentially, and seeing if you can get models to tease apart the trends and tease apart the patterns in the data that you think are going to be there or that you're looking for. Marc, I'll let you talk maybe a bit about use cases or ones that you can talk about.
Well, yeah, absolutely. And I would say if you just tweak a couple words in what Brian just said, that's a geophysicist, right? It's the same workflow, just different tools and a different data sets. That's the fundamental difference. I've always thought of geophysicists as very specialized data scientists using one specific type of data, but really data science is just the general case. In my world, yeah, absolutely same thing as Brian. The vast majority, or not the vast majority, but a small majority of our work is data pipelining. That's what I call it. Finding it from this dumpster, pulling it out, trying to clean it all up, putting it in another place, making some use of it. So I would say that's about a little under or over 50% of our job. And then we do a lot of dashboard science, I would say too, building dashboards, visual analytics as well. And then I'd say, good 20, 25% of our time is actually developing machine learning algorithms or some, deep learning work, that kind of thing. But they all feed into each other. So you need to do that foundational work at the very beginning, and then it kind of builds up from there.
Did that add up to 100?
With rounding error, no problem, yeah.
I don't know if you're allowed to talk about it, if it's proprietary. Can you possibly give us an example of something that you published in the past few years, Brian or Marc? Just to get a better grasp on what kind of stuff you guys.
Sure, I'll take this one initially, just so I'm not sure what you can talk about, Brian, but I'll give you one example. For instance, we're working on ESP failures, electronic submersible pump failures. It's not a geophysical project, it's an engineering project. But we're not trying to understand when they'll fail. That's not the issue. We'd like to understand why they fail. So it's an inference issue, not a prediction issue. And so that was great, and it's been done by the engineers, but what we were able to bring to the table as data scientists was survival analysis, which is what you typically use in the medical field. So if you give somebody a drug and then they live a long time, that's great, but if they die, you can use both sets of data. So that's what survival analysis allows you to do. So if a pump runs for an extended period of time, or if it dies, you can use both of those sets of data, which is wonderful. And that's something that we had never seen in our company anyway. So we used that, and that kind of doubled our data set, for instance. But our typical software doesn't have survival analysis in it, right? Because we're not a pharma company trying to develop a new drug. But these things are openly available in open source packages that we were able to bring over. So that's an example of one thing we've done.
That's a great example. And I don't know if you're able to mention anything that you worked on in the past, Brian.
Yeah, sure. I mean, I also see one of the questions in the stream as well, asking about using machine learning to predict well performance, and that's something that has been done quite a lot around the industry, particularly when you look at, say, an unconventional play, when you have a large number of wells in slightly varying geology, different completions, different parameterizations, different wells drawn different places in the play, and you have a variety of production results, and you're trying to understand the relationship between all those input parameters and one output parameter, which is the well's production performance, let's say 12-month cumulative performance or something like that. And as I've alluded to, those experiments are not perfect, and even if they are, as perfect as you can make them. We complete one well with one completion, and the well 400 meters away with a different one, and we get wildly different results. Like, we didn't actually have a perfect experiment there. You're subject to the tyranny of the earth, and there's always going to be differences. And so you're trying to use those statistical techniques to tease apart the impact of, say, completion design or geology. And that's been done quite widely across the industry for the last 5 years or so.
And you've sort of really touched on a lot of the work that I've seen, especially at a company like Synovus or Suncor, and we can probably talk about that for a long time, like especially creating models or algorithms with imperfect data and laws that you have to work around in that case. But I think we have a few more questions, Jeff. If not, we can come back to this topic because we can talk about it for ages.
Yeah, we actually have a question from Nita. Please step up to the mic.
Hi, this is really great. Thanks to you guys for putting this on. My question is related to automation. So where are you guys using automation? How are you using it? How are you using it? And are we, I know these are five questions. Are we as geoscientists in a place where we are able to automate now, or are we a few years away from that?
So Netta, what do you mean by automation? Do you mean like automating an Excel script, or like an autonomous vehicle like the trucks at Suncor?
Well, I guess anything where geoscientists are involved. So I would say just for example, I'm thinking, so myself, my background is passive seismic, and you're looking at earthquakes. Like I'm seeing hundreds of earthquakes on a regular basis. So automation there, I need that intervention. I can't get through it quickly enough myself, for instance. Are you guys experiencing those kinds of problems? Or are we a ways away from even using that type of technique or technology?
I would say that it's creeping in for sure. There's certainly a lot of papers trying the technique out. Where I think trying out such techniques, and if you take the example of, say, seismic interpretation, like surface seismic interpretation, that's kind of a big 3D image processing problem, or 3D image categorization problem, classification. There are tools out there to do that, but the people I know that I've chatted to developing those tools, they're still looking for the kind of ability of a geoscientist to provide feedback. You still don't have a great ground truth set for that. So you can interpret maybe the examples that I usually go through. I've interpreted inline across line, and now I'm going to flood the whole volume with the facies that I've interpreted. So it's like providing really like multi-dimensional seismic attributes and rolling all those together and doing that interpretation automatically. And the same thing for earthquake seismology as well. Like, there's a really nice paper looking at automated picking using machine learning models of seismic phases. But I still think that those require you think about what the data involves. It's not a clean problem. You haven't got always a great ground truth data set. And so I think there's still, for a long time, going to be a human involved. Is that human more powerful? Is that geoscientist a lot more powerful? And can they get to a lot more? Like maybe in the screening phase of looking at seismic? Well, yeah, probably. So does that mean that there's maybe fewer humans needed? Probably. But then there's also that kind of transfer of skills away from the kind of human involvement in seismic interpretation into the people that are driving or writing the algorithms.
True.
Yeah, I think studies have shown that there's nothing more powerful than a person and a machine working together. Those typically get the best results. And that's what we're leaning towards, is developing recommendation engines for anything, for trips, well trips, or that kind of thing. But it always has to be validated by a subject matter expert. So there will always be a person involved at some level.
I think the classic case is having some form of algorithm pick facies on a well log, right? You have just a very few inputs. It's good measurement of data. Pattern recognition should be pretty good overall, a multiple number of wells, but you're still going to want someone subject matter expert to take a look at that pick. And I don't think a computer is going to replace anyone immediately in the distant future, or not so distant future. So I hope that answers your question, Ada, unless you have a follow-up.
Yeah, just a quick follow-up. In your work specifically, Marc and Brian, I guess, Brian, you just started at Suncor, so maybe you need a little bit more time there. Are you guys doing, are we, by asking, are we a little ways away from that? I mean, are you guys seeing enough repetition in your work to sort of bring in automation into your work, or are we a little ways away from, incorporating that?
Yeah, that's a great question. Yeah, that's a great question. I think that's where it gets very interesting for geoscience, is that our data is relatively sparse. It's irregularly sampled. It's biased. I mean, we try to drill good wells. We don't drill a random sampling of wells, for instance. So I think, yes, for that reason alone, it will take a little while to get there. And like Brian said, you can drill 2 wells identically and get very different results. We've been leaning for those kinds of problems. We've been doing that more in the engineering space because it's process data that comes in more regularly. It's more evenly measured. And I would imagine if we had more, like we would do a lot of work with DTS data, so just distributed temperature sensing data. And if we start doing that with DAS data, which is the acoustic version, that is kind of like the perfect a hybrid of geophysics and engineering data in a sense, and we would need much more of it to get to that level of automation that you're thinking about.
Thank you.
Thank you for your question, Ada. Did you have any follow-up comments to that, Brian?
Nothing particularly. Mark nailed it. That is one of the problems. I guess one thing I would say is that as we look to kind of scale problems and make analyses a lot more automated, another part of it is that kind of operationalization, deployment of an algorithm or a set of techniques, and having a nice feed of data that comes in from, let's say, the field or from a facility or something like that, and be able to run that model on it, and then spit out some predictions. And so the data science role is kind of in the middle of that, building a model. But it's really hard actually to get all of that data in a nice clean fashion, in a nice automated way into a model or into an interpretation environment and spit out recommendations to users. And there's actually, I would say, at both ends of that, there's kind of gaps in the market. There's gaps in the sort of data engineering space where you're trying to put data, trying to get those data pipelines built. I'd say there's a scarcity of skills there, particularly with people who are familiar with the data that's coming in. And then also that kind of operationalization of a model and taking it out of, let's say, a notebook where it's been hacked together and deploying it where it can be used repeatedly. And that's, I think there's been a ton of focus on data science, and rightly so, for the last few years. But if you're looking to diversify your skill set away from maybe one discipline, I'd look at either end of that pipeline as well, particularly on the data engineering side.
Yeah. Honestly, if anybody asks me what's the first skill you should learn, I say SQL. That's real. You'll get much further ahead with that one skill than with almost anything else.
And that's a really good point. A lot of the problems that you guys probably face is how do you store information properly, and how can you get that information back? But on a different note, maybe we should see what other questions we have out there. Just to keep track of time, we do have about 15 minutes left. So get your questions in now before we run out of time. And to that, I'll give it to you, Jeff.
Yeah, we have a few questions in the chat, but we also have a few hands up. So just to touch on that, maybe that SQL comment, programming languages, like, what should one be getting into? I mean, Python's obviously pretty popular. Is there new ones coming out? Should be learning R? Is this dependent on maybe the type of data science role you have at a company? I'll let you, Marc, start that one off.
Yeah, I always just I kind of sigh when we go down this path because it's almost a holy war discussion, right? Short answer, if you're only going to learn one language, Python, because it's capable of everything. As what Brian indicated, it can do the entire flow. maybe not perfectly, but it can, right from, you know, the data pipelining to the analysis to the operationalization. So if you don't want to learn anything else, Python would be it, I would imagine. But like I said, SQL, please don't underestimate that. Most of the data we work with is numeric, it's tabular data, and it's stored in some kind of database, and SQL is the key to unlock that. I am pretty partial to R because it was built by statisticians and scientists, so it kind of works a little bit better with how I understand how to do things. For instance, in a list, R starts with number 1, Python starts with 0. There's a reason for both of those paradigms, but if you think one makes more sense, then you probably would lean a little bit more towards R. Honestly, there are other languages out there, like I love Julia, and I wish it would take over the world because I think it's probably kind of encompasses everything in one thing, but that's kind of far off. The key is that there's always going to be a new language, there's always going to be a new way of doing things, and so you have to be quite flexible and understand that whatever you picked up now may not be useful in 5 years from now, right? So right now, Python is the real deal, but it may be something different down the road. But once you pick one up, they get easier as time goes on.
Brian, is there anything you would add? Any languages that people should be looking at right now?
No, Mark got the question right, so it's okay.
Yeah, very religious, I can see.
No.
I think the more important question is it SQL or SQL?
Yes.
Yes, to both. Okay.
Yeah. One thing I would say, like as well, though, about say Python as a language. I was talking to a colleague about this the other day, and she just said, you know, it's very Googleable. And that's a big thing, that you can just find so many resources online, and it's also very legible as well. I think, like if it reads, it's kind of, it's not self-documenting, but it's nicely, you can read Python after a little while, and it's pretty obvious what it's trying to do. And so from that point of view, it's a really nice language to get into. And I think like starting lower level, I think my programming language history is probably Fortran, then C and command line, and then C++ and Java, and then a bit of SQL in there on the way, and then eventually to Python. And like, God, I wish it was the other way around. I wish it'd gone the other way, because it's much nice. I'd say higher level is good if you're completely new to programming. By high level, I mean where you don't need to write a ton of really detailed code to get it to do something. So start there and start with a language that's legible and flexible, and Python is a great example.
Mm-hmm. Brian, you've coded a lot, and you just mentioned a number of different languages. Can you comment on, say, once you're fluent in one language, how easy it is to pick up another language, even though the syntax can be completely different?
I think it's, you know, once you've got one or two under your belt, like there's a lot of commonality. I haven't really been programming Python that long. I'm not saying I'm great at it. I'm really not. But there's a common structure to a lot of them, and you'll find it very transferable. I mean, this is not. I really wouldn't get hung up on which language to choose. You know, just pick one and work with it for a bit. And you'll find that if you didn't know one and you all of a sudden you do, that's a game changer. And the other part that we haven't really hit on, but it's really important, is the number of power. And this is another reason for the proliferation of these tools in the workplace, is the number of these tools that are available for free online. And you can look like an absolute rock star with some very limited programming skills, just sticking together stuff that people who are way better at coding than you are can do. Like, and that's not all I do day to day. That's really not. But but there's a component. You're incredibly powerful with just a few skills.
Awesome. Thank you for your answers. Jeff, who do we have next?
Forgive me for if I mispronounce this, but Ju Zhang. If you have a question, could you please speak into the microphone?
Yeah, and thanks, Mark and Brian, for this good, wonderful conversation. For my question, I'm just wondering what's your opinions on cloud computing, and what's its current status here, like in its application in the oil and gas industry here in Calgary, and Yeah, that's my question. Thank you.
That's a fantastic question. Marc, if you want to start us off.
Sure. It's the next evolution, right? I mean, in terms of, going from your laptop to a big workstation under your desk, eventually the amount of data coming in will be too big. And the only solution really at this point for large data sets is the cloud, because it's just somebody else's computer, but it's much bigger than the one you have, right? So knowing those skills actually is quite critical, I would say. Oil and gas is still kind of hopping along that train. It's not quite as mature as I think we'd all like it to be, but it's definitely very, very useful. And that is an exceptionally marketable skill in many other sectors as well. So yes, it's just, I guess there's just another tool, it's just another computer, but it's a key component of how things operate these days.
And Brian, are you seeing Suncor take advantage of cloud capability as well?
Yeah, we do, but I would echo Marc's comment that there's a real difference amongst different companies in oil and gas about how hard they've embraced cloud. And some people have even posited, I've seen at certain talks, that there'll be kind of two populations of companies are evolving, and it's those that are embracing the new way, and there are those that are not. Now, whether that's fair or not, I don't know. But I guess we'll know in the fullness of time. I think that just another comment on, as I mentioned, about ingesting data and some of the tools that are available to process data, that combined with the knowledge of cloud is increasingly valuable. I wouldn't say I know a lot about this myself, honestly, but it's a skill set, it's an area where if you can learn how to manipulate data and pull it into a cloud environment and work with it there, that's a hugely valuable skill as well. And like Marc says, cross industry.
Have either of you run into problems that you tried to solve that your standard desktop wasn't able to crunch in a reasonable amount of time? Or has everything you've been working on, you have a finished product if you run it over the weekend, worst case scenario?
Unless you have go ahead, Brian, sorry.
I'll give one really short anecdote about that. When I kind of was first dabbling with this, and I'm sure Marc has answers about the scale of data sets you just mentioned that would be cloud worthy or not worthy of anything other than the cloud. When I was first just poking around with a 3D convolutional neural net for doing seismic interpretation, there was some freely available code online, downloaded it, ran it. And I ran it on my laptop, and I think one iteration of training took about 40 minutes. And so I logged into my desktop at work and set it up there, more powerful machine, and it took about 10 minutes. And then I spun up a cloud GPU and I ran one iteration there, and it took, I think it was 5 seconds. And that to me, it was just that progression. It's like, okay, wow, I get it now. I was sold. But yeah, I haven't done a ton of cloud related work in my my career so far, but I know that Marc has been a lot more involved.
Yeah, so absolutely. Time spent, once you get a GPU involved, it makes all the difference. The other aspect is just sheer size of data. If you're looking at tens, hundreds, thousands, even up to a few million observations, chances are a laptop might be okay to do that. Once you get past that point, you have to go to some distributed computing system, and that's typically a cloud system, right? If you're looking at billions or even potentially trillions of observations. We do have a current, in our DTS environment, we have 85 billion records right now. So it's just, a laptop isn't feasible, period.
One thing I just thought of, so using cloud computing is actually probably pretty expensive and prohibitive for students. Is there ways they can, get experience free or low cost, how to work with data in the cloud?
Yeah, that actually was a great point, Jordan. I actually did that with AWS. There's a free tier that you can use. It's usually on small data sets, but I actually did that, and I was doing stuff in there, and that was actually quite impressive to my management at that point. Said, wow, okay, you can do that stuff. And so yeah, there's a lot of potential there. It's a very slippery slope with the cloud. That's one of its downfalls, is that it has a very opaque cost system. and you can do things that end up running bills very, very quickly. So you do have to be a bit wary of that. But no, for instance, AWS is the one I'm most familiar with. Does have a free tier, and I ran it for a year, and I think I paid a total of $1. So as long as you monitor everything, even understanding how to monitor your costs is a very useful tool. That would be that's another really burgeoning field, is actually cloud accounting, to be honest, because every company wants to use these tools, but nobody really understands what it costs yet. So that's another pro tip there.
I don't even understand my cell phone bill, so I'm sure I'll take an expert to look at that. Jeff, maybe how many, do we have a few questions out there? Maybe take one more. We don't want to keep these guys too late. They've been generous enough with their time.
Perfect. Yeah, we'll take Paulina for a verbal question here.
Hi everyone, I had a question about this cloud computing services. So is there any preference in your companies for AWS or Azure maybe, or can you comment on that?
Yeah, I mean, we've signed a kind of a partnership with Microsoft on Azure, and that's kind of been an ongoing thing. It's FunCore for I think a year, maybe two, maybe it was announced last year, but that's where the bulk of the work is done. And Marc, you might give a different answer. I don't know.
Yeah, I mean, basically it's a corporate discussion. We can't just spin up our own little cloud environment. There are a lot of data and governance issues around that. So we've signed an agreement with AWS. So that's our preferred vendor, so to speak. So it's not a choice like Python or R at this point. It's really what the company allows you to use.
Okay, because Cole just had a follow-up to that, and it's along the same line. Is Azure versus AWS, same type of idea as Python versus R? Is it preference? But it seems more like the company you're working with. Would you say that if you had skills in one or the other, just as a self-learner, that you'll be fine using either in the future?
I really can't say that you should learn one versus the other. I think it's just the experience of being in the cloud is probably the most important part.
Perfect. That answers that perfectly. And with the last remaining couple of minutes, this is such a broad field. Where can people who tuned in tonight, learn more? What kind of user groups are there in Calgary? Is there anything they should be looking up? Where can they just find some more data, get more involved? Marc, I'll let you answer that because I know you have some involvement with some groups in Calgary.
Thank you so much for that, Jordan. You're letting me put in a plug right at the very end here. So I'm quite active in the meetup space, so meetup.com. There are quite a number of different active groups in that world. I used to be part of the Calgary R group. There's a number of Python groups. My current meetup is called Untapped Energy, in which we basically discuss analytics within the oil and gas space. And recently it's kind of turned more into kind of a career pivot kind of world, where we've discussed people who pivoted from oil and gas into various data careers currently, who've done it successfully. So yeah, just take a look at that, untappedenergy.ca. But yeah, many of them out there for every flavor of the data science world.
Perfect. And Brian, do you have any special tidbits of places where people can look for some more information?
I can't claim, I'm afraid, to be as involved in some of this community stuff as Marc is, but I think the stuff he's doing is amazing, really good. The place that I've been a member of for, I don't know, quite a few years now, I just looked and it has 3,000 members. It's the Software Underground, and that has a lot. That's a lot of kind of data focused geoscientists. It's kind of a gathering place for them. That's a Slack workspace, and you can find that by just going to swung.rocks in your browser. I just checked that still works. It used to be a really confusing URL, but yeah, swung.rocks. There's a bunch of really great resources on there, and like I say, a lot of like-minded people.
Perfect. What I'm going to do is I'm going to summarize all those juicy tidbits that Marc and Brian just gave us. I'm going to put it out into the email to everyone who joined us tonight. If anyone has any questions after they've sort of thought about this this chat we've had, can they pass them on to us and we can give them to you guys? Are you guys willing to accept some questions beyond this? I'm sure you guys have been pretty awesome. I'm hoping we can just tease a few more answers from you guys. So yeah, it sounds like that's the case. So if you guys have any questions, feel free to email them to Jeff or myself. Jeff sent out the registration email to all of us in the first place. And I think that wraps up our second AMA of the year. Just a huge shout out, a huge thanks to both Marc and Brian for contributing tonight. We hope they answered some questions that you had or didn't even know you had about data science and data analytics. And on that note, we just have a little thing to announce. Our next session. Oh geez, which screen am I on? Am I on the right screen?
I don't think so.
Okay. All right. So we already have our next AMA session planned. We're going to be joined by Amanda Hall and Sean Gorman. They're from Summit Nanotech, and this should be a very interesting conversation. You know, leadership, entrepreneurship. They're also working in the lithium space. We don't have a date decided yet, but think around, you know, the 6 to 8 week mark. We're going to send out some advertising much before the event itself. So keep an eye on your email box for that. And with that note, I think this is a good time to end. Thanks everyone for joining us. I hope you guys got as much out of it as I did. And with that, we'll say goodbye. Thanks a lot.